All right, so let's now investigate whether sine and cosine are even or odd. Okay, and so in order to do that, we're going to look at this little picture here, and let's just write in the coordinates. Let's say that this intersection here happens at A, comma B. And then let's say that this one down here, well, think about this for a second. If this one is at x equals a, then so should this one, assuming that theta and minus theta are just different. They just differ by a sign. Okay. Right. And then if we were to look at the y value, their y value should just be the opposite. So minus b. Okay. And so what we're going to do is we're going to work with this picture now. We know that sine of minus theta is equal to, so we're going to be looking at this negative angle, and sine of minus theta is the y value, so it's minus b. Okay. And if we were to look at sine of theta, well, it's equal to positive b. And so what this tells us then is that sine of minus theta is equal to minus sine of theta. And so what that means then is that sine is an odd function. Okay, sine is an odd function. Okay, so it's going to be symmetric about the origin. Let's see. Let's deal with cosine here now. Okay, so if we were to look at, say, cosine of minus theta, we can see from our picture that cosine of minus theta is equal to a, and cosine of theta, based on our picture, is equal to also positive a. Okay, and so what we see here then is that cosine of minus theta is equal to cosine of theta. Okay, so that means that cosine is then even. Okay. What we've done here isn't actually a proof, but if you took this argument and you applied it to any of the four quadrants, it would work out. Okay. Let's move down here a little bit. So the even functions here are actually going to be, for one, we saw up above, cosine. Okay. And the other one is actually going to be secant, 1 over cosine. Okay. And we could verify this. Another way to think about it is if you were to do 1 over cosine, you're doing 1 over an even function. And in fact, 1 is actually also an even function. So you have an even function over an even function, which will result in an even function. Okay. And if we were to write out these rules for cosine and secant here, we already technically have the cosine one, but so cosine of minus theta is equal to cosine theta, and the same exact thing could be said about secant. Okay. And this can be helpful if we have a negative angle, we can just think about it as being positive. Okay. Let's try another one. So the odds. So we saw that sine was odd. Trying to switch colors here. Okay, green it is. Sine was odd. It actually ends up that 1 over sine, which is cosecant. is also odd. Okay. If we have an even function over an odd function, we'll end up with an odd function. Okay. And then we have tangent and cotangent, which are also, well, tangent is an odd over an even, which will also give you odd. And cotangent, that is an even function over an odd function, and again, that will give you an odd function. Okay. And we could write down the rules here. Sine of minus theta is equal to minus sine of theta. Cosecant, so cosecant of minus theta is equal to minus cosecant of theta. And tangent of minus theta is equal to minus tangent theta. And then one last one for cotangent. There we go. All right, we've moved on to page 6 here. And what we're going to do is make an attempt to use those even and odd properties to evaluate our trig functions. Okay. So let's start off with this sine of minus pi over 4. We know that sine is an odd function. So what that means is we can really pull this negative out front. And then all we have to do is go to our unit circle and figure out what sine of pi over 4 is. Okay. And if we go and do that, we'll find that sine of pi over 4 is equal to the square root of 2 over 2. Okay. But I want us to think about why this was helpful to do this in the first place. If I go to my unit circle here, you will not see any negative angles, right? You see angles between 0 and 2 pi. Okay. So that's really the real reason that this is helpful. But I want to point out that you could do this still, even though you don't see negative angles here, you're aware that negative angles result from clockwise rotation. Okay, so if we look back at this, it was minus pi over 4, right? Okay. So if I were to rotate negative pi over 4, that would land me right here at 7 pi over 4, right? Because 2 pi minus pi over 4 would be 8 pi over 4 minus pi over 4, which is 7 pi over 4. Okay, so that makes sense. Okay. And again, this was sine, right? And so sine's the y value, and we should get minus the square root of 2 over 2, which is what we get. Okay. So we could have thought about it this way too. All right, let me get rid of this, and then we'll go back and we'll try the other one. Okay. There we go. So let's remind ourselves of what, well, actually, we don't need to do that yet. It's really up to us whether we want to rewrite this in terms of cosine right away, or just use the fact that secant here is even to begin with. If we go with that, then we could just rewrite this as secant of 7 pi over 6. Okay. Again, this is nice because minus 7 pi over 6 might be harder to think about where that is on our unit circle. Okay. And then secant is, again, 1 over cosine. So this is what we're really trying to compute, is cosine of 7 pi over 6. And we'll just do 1 over whatever that is. Okay. Let's go to that unit circle. And if we find ourselves 7 pi over 6, that is right here. Okay, and cosine is the x value, so we have 1 over minus the square root of 3 over 2. Okay, and so we get the reciprocal, and then we will rationalize the denominator. Okay. But again, I want to show you that we could have done this a slightly different way, right? But do keep in mind we had 1 over minus the square root of 3 over 2 with this technique. Okay. We simplified it, but we had that. Okay. Let's try and do secant of minus 7 pi over 6. So I'm going to go to my unit circle, and we are going to rotate minus 7 pi over 6. Okay. So right here would be pi, and if you add one more pi over 6 to this, that'll be 7 pi over 6, and so that will put us right here. Okay, this is minus 7 pi over 6. Okay, and now look, if we did do 1 over x, that's 1 over minus the square root of 3 over 2, just like we had. Okay, so we didn't have to use the fact that secant was an even function, but it did make it easier.